Let's talk CPI tables. So you have a list of years and a number associated with each year. What do those numbers mean? CPI stands for Consumer Price Index, so that gives you a little information. It has something to do with prices, specifically consumer prices, what regular people pay for end products. But we need a little more. Think of all the things everyone in the country spends money on in the course of a year. Not businesses, but just individual people. Groceries, gas, cars, rent, houses, entertainment, clothing, the list goes on. Now, imagine all those things being merged together into a single imaginary project, an average of everything everybody spends money on. So here's our conglomerate project I'll refer to as stuff. The CPI values are just each year's price for one unit of stuff. So in 1980, it cost $82.40 for one unit of stuff. In 2000, the same amount of stuff cost $172.20. This means that $82.40 in 1980 was equivalent to $172.20 in the year 2000. Now we start using this information to solve problems. The most basic type is what you see in your homework. You are given the cost of an item in one year and asked to find its cost in some other year's dollars. Note, you're not finding the item's actual cost in the other year. More on that in a bit. Let's look at an example. The average price of a gallon of gas in 2017 was $2.42. What would this price be in 1997 dollars? We solve this type of problem by setting up a proportion. We take the given price over its corresponding CPI value, set equal to the converted price over its corresponding CPI value. In this case, we have the 2017 price over the 2017 CPI value is going to equal our unknown, the converted price, over the 1997 CPI value. So 242 over 245.120 equals X over 160.500, and then you solve the proportion by cross-multiplying and dividing. 242 times 160.5 divided by 245.12 equals 1.58457, etc., rounds to about $1.58. Again, this is not the actual price of gas in 1997. All we've done is said if gas costs the same in 1997 as it did in 2017, it would be $1.58 per gallon. That $1.58 in 1997 is equivalent to $2.42 in 2017. I can go a step farther and tell you the actual price, the actual average price of a gallon of gas in 1997 was $1.20. So what does this tell us about 2017 gas prices versus 1997 gas prices? Well, the 2017 price of $2.42 is equivalent to $1.58 in 1997, but gas actually cost less than that. It cost only $1.20 in 1997, so the price was lower, even adjusting for inflation. You may see this type of problem presented in other ways. Sometimes you may be given a table of years and CPI values and that year's actual price for some item. Maybe you're given a CPI table along with a few selected years' actual prices. There are a couple of different approaches you can use to solve these. One is what I've just done. You first ignore all but one of the actual prices. So I didn't have this $1.20 to start with. I found the $1.58 and then I compared to the $1.20. So even if I was given the $1.20, I could start at ignoring that, find the $1.58 and then compare. So let's look at another example of this. Suppose a bottle of soda cost 10 cents in 1972, 50 cents in 1992, and 125 cents or $1.25 in 2012. In what year did soda cost the most? Well, the 10 cents from 1972 is equivalent to 33.6 cents in 1992, as you can see from this calculation I've done. And it's equivalent to 54.9 cents in 2012. Here's the calculation set up for that. So I put these together. The actual price in 1992 was 50 cents compared to the 1972 adjusted price of 34 cents. So the actual 1992 price was higher than the 1972 price adjusted for inflation. And likewise, the 2012 price was higher than the 1972 adjusted price for 2012 of 55 cents. Now, you may be tempted to guess that 2012 is higher than 1992 if you compare them, and you may be right, but this is a math class. You always need to back up your guesses with mathematical evidence. So to do this, we can directly compare the 1992 and the 2012 prices. So we take, for example, the 50 cents from 1992, convert it into 2012 dollars, and we get 81.8. So yes, the 1992 price is still, even adjusted for inflation, lower than the 2012 price. So we've said that the 1972 price is the lowest and the 2012 price is the highest, and it seems like, well, obviously, because $1.25 is more than 10 cents and 50 cents is the middle. So, but those original prices given are the amount in that year, and money was worth less, or the same amount of money could buy more in 1972 than in 2012. So we're looking at a deeper meaning of cost, not just the numerical amount of money, but the actual worth of that money. So the second way of comparing these values uses simpler calculations, but it may be a bit harder to understand what's actually being calculated. So for this method, you simply divide the actual price from each year by its corresponding CPI values. So we take the 10 divided by the 41.8, get 0.239, 50 divided by 140.3 and get 0.356, and the 125 divided by 229.594 to equal 0.544. Notice I used the cents in all of them, or I could have also converted the 10 cents to 0.1, the 50 cents to 0.5. The main thing is that you're consistent. So I have these three numbers. I can see that the 1972 number is smaller, the 1992 is in between, and the 2012 is the biggest. But what do these numbers actually mean? Well, we're going back to our stuff. So a smaller number corresponds to a lower cost. And what we've done here is divide the price of an item by the unit cost of stuff. And since we took a price divided by a price per unit, we end up getting a number of units. So we're finding out how much stuff could have been bought for the price of a bottle of soda in each year. So for the 2012 amount, we get about half a unit of stuff here with a 0.54. For the 1992, we got more like a third of a unit, and for the 1972, it was only worth about a quarter of a unit of stuff. So we can see how much stuff each of these bottles of pop was equivalent to in those years. And that tells you, again, that you're spending more, you're giving up more other stuff to buy that bottle of pop in 2012 than in the other years. Now I'd like to look at one more type of problem using CPI tables. We have compared the prices of items, but you can also compare amounts of income. In this case, we talk about the purchasing power of an amount of money. That is, how much stuff you can buy. You can use either approach, but in this case, I think the second is more intuitive. Take the amount of money and divide it by that year's unit price of stuff, the CPI value. Let's look at an example of this. A person working full-time for minimum wage in 1980 would make $6,448 per year. In 1990, they would make $7,904, and in the year 2000, they would make $10,712. So we want to compare the purchasing power of these incomes, see which of these was the best income. So we'll divide each of these incomes by that year's CPI value. And we get these values 78.25, 60.47, 62.21. So that person working for minimum wage in 1980 could buy 78 1/4 units of stuff. In 1990, working minimum wage, they could only buy about 60 1/2 units, and then in the year 2000, they were up a little bit and can now buy a little over 62 units. So we can see here that the lowest minimum wage income as far as purchasing power was in 1990, that could buy the least stuff, and the highest by a good amount there was in 1980. They could buy quite a bit more units of stuff than the other years. We could also have used the first method. We could convert the 1980 wage into 1990 money and into 2000 money. We'd see the 1980 would be equivalent to 10,228 instead of the actual 1990 income of 7,904, so a good bit more. And the 1980 income converted to 2000 money should have been 13,475 instead of that 10,000. Instead of that 10,712. So the 1980 was higher than both the 1990 and the 2000. Then directly comparing the 1990 and the 2000, the 7,904 from 1990 converted to 2000 money comes at 10,414, a little lower actually than the real 2000 value of 10,712. So the 1990 was lower than the 2000. I hope this helps you to understand the calculations you're doing with the CPI table that you've seen in your homework, quizzes, and tests.